Trigonometry, sectors of circles. The formula for the perimeter of a circle, the distance around a circle, is given by 2 pi r. And the formula for the area of a circle is pi r squared. This is in your tables. A sector of a circle is a part of a circle. In this case, the length of the arc from P to Q, or a bit of the way around a circle, perimeter is given by 2 pi r times a over 360, where a is the angle here between POQ and 360 is the total angle that exists within the circle. So the smaller a is, the smaller this arc will be. The area of the sector is given by pi r squared, again times a over 360. So if a turned out to be 360, it would be the whole circle. If a turned out to be a quarter of it, it would be only a quarter, 90 over 360, etc. So the formula are given in your tables: perimeter of circle, length of arc PQ, etc. for both the area of a circle and the area of a sector. R is the radius of the circle or the sector, and A is the sector angle. So here's an example of a question. Find the size of the area shaded red. So here we have a sector with a triangle cut out of it. And we've got to find this, the size of the area shaded red. We're also given numbers here. We're told that the radius is 20, 20, and it's a right angle triangle here. It's a 90-degree angle. So we'll start now by finding the area of the sector, the whole sector. So the whole sector shaded in green. Well, the perimeter of the circle is given by 2 pi r, or 2 pi times r in this case, the radius, 2 pi times 20, or 40 pi. The length of the arc of the PQ going around the outside is 40 pi, the same as the perimeter of the circle, times 90 over 360. 90 over 360 is a quarter, and a quarter of 40 pi is 10 pi. Similarly, the area of the circle, if we look at that, is pi r squared. In this case, r is 20, so it's pi 20 squared, or pi 400, or 400 pi. And again, the area of the circle is this ratio, 90 over 360, the a over the total, 360 in the circle, or a quarter, so 100 pi. So we now know the area of the whole sector. We were asked to find the area shaded red. So the area of the sector with red and green, the whole sector, was 100 pi. Now let's look at the area of a triangle. This is just the green area here. This is an isosceles triangle because both sides, the 20 and the 20, are similar. Also, usefully, this is a 90-degree angle. So this line here is perpendicular to this. So if this were the base, this would be the perpendicular height. So to find the area of the triangle, we can use the formula half the base by the perpendicular height. In this case, half the base, which is the radius here, times the perpendicular height, half 20 by 20. And that's a total of 200. There is an alternative method to calculating the area of the triangle, and that's using the half AB sine C rule, or half two sides and the angle in between. Well, we do know two sides, this side and this side, both radiuses, and here the angle in between. So a half 20 by 20 sine of 90, and sine of 90 is 1. So a half of 20 by 20 by 1 is again 200. Exactly the same as we got for the perpendicular height. So the size of the red shaded area is simply the total area for the total sector, which turned out to be 100 pi, minus the 200 we got for the triangle.